Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics and specifically the topic of statistics. We'll be looking at the past paper questions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help create other videos that will assist you in whatever areas that you are struggling with. Don't forget to look at the description down below where we have suggested an order to go through the entire CSEC Math syllabus for you to get a better grasp of all the content. Let's look at the 10 major topics in CSEC Mathematics, and our focus in this video is on the fifth topic, statistics. This is tested in the multiple choice paper 1 for 6 questions out of the possible 60. And in paper 2 for 9 marks out of the 100 marks. Let's recall what statistics is. It is a branch of mathematics dealing with large collections of data or information. And it can be presented in terms of different formats. So if we consider that, then we can subdivide this into data being either in an ungrouped or grouped, and that the statistical diagrams that may be presented with it includes pie charts, bar graphs, line graphs, usually in the ungrouped section, and histograms, frequency polygons, and cumulative frequency curves or ogives in the grouped section. Not just that, but we also must take into account that there are central tendencies that we can get from both factors, whether it's grouped or ungrouped, such as the mean, the mode, or the median, and also measures of dispersion, which include calculating the range of the data, the interquartile range, the semi-interquartile range, and even the standard deviation. As we look at the third in our series on statistics at the past paper questions, in 2019, it was based on the statistical diagram of a histogram. And of course, in 2020, there was none because of the COVID-19 pandemic. And in 2021, it was based on some tendencies, including finding the mean, the mode, the median, and probability. In May 2019, number 7, the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150, that's important, 150 different vehicles is shown below. Now they're giving us a table with 2 columns and I'm putting in a third one. So we have weight in kilograms, which is from 11 to 20, that's the class interval, and the cumulative frequency is 24. I have added a third column of frequency alone. And the second interval is 21 to 30. That means the cumulative frequency, if we add up the frequencies of the first and second column, will give us 59. So what that means that in our first interval, we had 24. In our second interval, to reach 59, would be 24 plus 35. So that would be our frequency of our second interval. For our third interval, 31 to 40, the cumulative frequency is 101, which means for it to move from 59 to 101, it required 42 in this third interval. And for the fourth one, 129, which means 28 is the frequency. And for the last one to reach 150, which collaborates with the 150 written above, it means we needed 21 more in this fifth interval. For part A, for the class 21 to 30, determine the lower class boundary. So 21 to 30 would be our second interval. And we can see there that 21 is our lower limit. If we're looking for our lower class boundary, it means that we're closing up the space between the 21 and the 20 from the first interval. As such, to close up the space, it means we're meeting halfway between 20 and 21, which would be 20.5. And the class width would mean, there are a couple of ways to work it. One way would be just going vertically downwards and seeing how much the number is being increased. And 11, you need to add 10 to that to get 21, and add 10 again to get 31, and so forth. Similarly, for the upper limit, 20, you need to add 10 to get 30, add 10, 40. So the class width is 10. In part B, how many vehicles were recorded in the class 31 to 40? That is in the third interval. It is not 101. That will be the cumulative, which means that it's adding all three intervals. We are only requiring the third interval, and that frequency is 42. 101 take away 59. In part C, a vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters? And of course, leave your answer as a fraction. So in our last interval, which is the probability that they require, then there were 21 vehicles. How did we get that? 150 minus 129 is 21, all over the total of 150. So 21 over 150. We can break it down if you want, or we can leave it as is. In part D, Byron estimates the median amount of petrol, the median, which means middle, right? The median amount of petrol to be 43.5 liters. Explain why Byron's estimate is incorrect. Now we have 150 vehicles. The middle of that will be the 75th. And if it's the 75th vehicle for that tank, then that means it falls within the third interval. The first 59 vehicles falls in the first two intervals. From the 60th vehicle to the 101st vehicle, those 42 vehicles fall in the third interval. So 75 or the 75th vehicle falls there. As such, a median must be somewhere in that third interval between 31 and 40. Notice that he's estimated it to be 43.5, which would not be in that interval at all, but in the fourth interval. So 43.5 liters is in the fourth class. That's why it is incorrect. And in the last part of the question, on the partially labeled grid, construct a histogram to illustrate the data. So, as usual, we'll be plotting a graph here, and it'll be a graph of frequency versus weight in kilograms. Weight being our x-axis, and since I'm labeling across, I've moved 0, 10, 20 up to 60, right? As my 2 centimeter columns, I have enough space for that. And going upwards, following their format, 0, 10, 20 up to 40 will be our frequency. Now I'm plotting. They want us to plot a histogram. First of all, for students to understand, to get a better grasp of it, I'll plot a bar chart. So in the first interval from 11 to 20, I'll plot it in light blue, and it will go up to a height of 24. Now we're not plotting cumulative frequency, we're actually plotting the frequency only. So there were 24 in the first interval, so it goes up to that height. Remember that from 20 to 30, there are 5 spaces, right? So 5 spaces will give us a frequency of 10, so 1 space will be 10 divided by 5, which is equal to 2. So 20, the next small block will be 22, and the following block will be 24. We're going up in small little increments of 2. And for the second interval, 21 to 30, plotted it in red, goes up to 35. The third interval in purple goes up to 42. Then the fourth one in pink goes to 28. And the fifth one is in green, it goes to 21. Notice that there are spaces in between all 5 columns. As such, this is a bar chart. Let's convert it to what they wanted, which is a histogram. And we can see that all 5 columns, we've now expanded it to the right and left, a total of 0.5. If you notice that the lower intervals will move by 0.5 less, and the upper limits will move to 0.5 more. So 11 became 10.5, 21 became 20.5, 31 became 30.5, 40.5, 50.5, and of course 60 became 60.5. May 2021, number 5, part A. 100, and that's important, 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows the results as well as the midpoint for each class interval. So we can see the table where it has 3 columns, the first being the amount of money that the students spent, and is arranged in group data, where the first group is from 50 to 60 and each group increases by 10, 60 to 70, 70 to 80, and so on. And the number of students are given, and we can double check that if we tally and we 7, 11, 31, 29, and 22, we will get 100, which coincides with the 100 students given above. And the midpoints of each of these groups are given: 55, 65, 75, 85, and 95. As such, we can now, according to Part A, determine the modal class of the amount of money spent. And we can see by looking at the frequency that the one which is most frequent is the third class interval. As such, that is the modal class. 70 is less than x, which is less than or equal to 80. And for Part B, calculate an estimate of the mean amount of money they spent correct to 2 decimal places. In doing this, I'm adding a fourth column, fx. So if we multiply f times x, 7 times 55, it will give us 385. And why we are doing that, we are making an assumption that all the students who fit into this category averaged about $55. And there were 7 students, so 7 times 55 will be 385. Similarly, in the second interval, we assume the average should be the midpoint, 65. So 11 times 65 is 715. In the third, 2,325 when we do fx. Fourth, 2,465. And the last group, 2,090. And we can total this sigma fx, the total of all the fx values, and that gives us 7,980. So in calculating the mean, or x bar, that is equal to sigma fx over sigma f. And we already have sigma fx, which is 7,980 divided by sigma f, which is 100. And that will give us $79.80. And in Part 2, Damien reports that the median amount is $84. Briefly explain why Damien's report could be correct. So let's look at the amount of students there are in all, 100 students. And exactly halfway in that will be 50. As such, we're trying to figure out where does the 50th student lie, in which class interval. We can see in the first interval there are 7 students, and the second 11. So by the time the second interval is finished, 7 plus 11, 18 students are taken into account. And in the third, another 31. So 31 and 18 will give us 49 students. Thus, the 50th student falls in the fourth class interval. 80 is less than x, which is less than or equal to 90. As such, it is possible that the report which Damien gave, which assumed the median to be $84, could be correct because it lies within the fourth class. In Part B, the two-way contingency table below gives information on the mode of transportation to school for 100 students. And we can see from the table that there's some information given about how boys and girls get to school, whether they walk, they cycle, or they drive. And Part 1 asks us to complete the table by inserting the missing values. And there are many different ways we can approach this. So if we look at the boys, the row, that first row there, we see 15 walk and 14 drive. That's 15 and 14 is 29. So 29 and how much more that cycle will give us 48. And that answer will be 19. So if we add across 15 plus 19 plus 14, that will give us our total 48. In this first column coming down, how many students walk in all? 23 students. We have 15 of them are boys, so the rest will be girls. As such, there are 8 girls who walk. And if we come down in the second column, then we look at who is cycling. There are 19 boys cycling, which we worked out already, and they gave us 18 girls. As such, the total will be 37 who are cycling. And finally, if we look at the column the row going across with girls, we have 8 that walk, 18 that cycle, and 26 that drive. So if we add that, 8 and 18 is 26 and 26 will be 52. And as such, 52 girls in total. And this, if we add 48 boys and 52 girls, it gives us 100. So as such, it tallies right around. So we could double check our answer. In part 2 of this, a student is selected at random. What is the probability? So probability means that we are looking for a fraction. What is the probability that he or she was being driven to school on that day? So how many students were being driven? 40 students, but we're writing it as a fraction, so 40 out of the total, which is 100 students. So 40 over 100 will be our probability. In part 3, one of the girls is selected at random. What is the probability that she did not cycle to school? So we're only looking at the row with girls. We can see that if she did not cycle to school, that means she either walked or drove. So 8 and 26 is 34 out of the total number of girls, because this is only looking at girls, so 34 out of 52. In both probabilities, we can reduce if we wish.
May 2022, number 5. A school nurse records the height, 8 centimeters, of each of the 150 students in Class A who was vaccinated. The table below shows the information. And as we look at the table, we can see that they put them into groups. Part A. Complete the table below and use the information to calculate an estimate of the mean height of the students. Give your answer correct to 1 decimal place. So, if we look at the table, we can see in the 4th row, the midpoint and fx, those values are missing. So what's the midpoint between 120 and 140? Well, the midpoint is 130. We can add up the 2 and divide by 2. And what is the fx value? It will be f times x, 67 times 130, and we can use our calculators for that. And that will give us 8,710. And now we need to find the mean. In order to find the mean or average, we need to find the sigma f, the number of students, which is 150, or they gave us that before as well, because there are 150 students in Class A. And sigma fx, so we can add up all the fx values using our calculator, and that will give us 18,320. So, in order to calculate mean, which symbol is x bar, that is equal to sigma fx over sigma f. And if we substitute, it will give us 18,320 over 150. And the answer works out to be 122.1, because we want our answer to 1 decimal place. Part B. In Class B, the mean height of the students is 123.5 centimeters, and the standard deviation is 29.87. For Class A, the standard deviation is 21.38, and we also worked out the mean height of Class A in Part A, 122.1 cm. Using the information provided and your response in A, comment on the distribution of the heights of the students in both Class A and Class B. So let's bring up a little sketch, and we can see 122.1 cm, which is the average height of Class A, and that has a deviation of 21.38, meaning that 1/3 of the students are within 21.38 centimeters above or below that average mark of 122.1 cm. And if we compare it to Class B, the mean or average height is a little more, 123.5. So that means generally the students on average are taller in Class B than in Class A. And the standard deviation is 29.87. It's wider. As such, the distribution of the height of the students is greater. So the graph itself will be a wider graph in Class B. May 2022, number 5C, Part 1. Complete the cumulative frequency table below and use the information to construct the cumulative frequency curve. So if we look at the table that they've given us, we're missing two pieces of information in the third row, the cumulative frequency value, and in the fifth row. And how do we get cumulative frequency? It's the total frequency at that point in time. So at the end of the first row, there were 4 students, so the cumulative frequency is 4. At the end of the second row, we added 20 more students, so 4 and 20 is 24. So at the end of the third row, 24 plus 35 students from the third row will give us 59. And by the time we do the fifth row, we had 126 students, and we added 20 more, so that will give us 146. Use your cumulative frequency curve to find part A, an estimate of the median height of group of the students. So let's bring up the cumulative frequency curve that they gave us in the exam. And if you notice that there are 1, 2, 3, 4, 5 points already plotted, and 2 points which are missing are the 2 that we filled out in row 3 and row 5. Let's plot those points. So at 120, the cumulative frequency curve is 59, and at 160, the value will be 146. And now let's complete the curve. So part 2, use your cumulative frequency curve to find part A, an estimate of the median height of the group of students. So if we want to find median in a cumulative frequency curve, then let's look at the y-axis, and what's our maximum value? 150. So the middle of that is 75. So if we go to 75 and we draw a line going across from the y-axis at 75, going to the right, we have it in red, and where it intercepts the curve, we come downwards, and that value there, which is 124 cm, will be an estimate of the median height of the group of students. And part B, last part of the question, use our curve to find the probability that a student chosen at random would be taller than 130 centimeters. So if we look at our curve, where do we get 130 centimeters? From the x-axis. So if we go on the x-axis and we draw upwards a purple dotted line until it hits the curve, and then we go across to the left, we can see that the cumulative frequency at that point will be 92. So what do we want? We want a probability. So what's the probability that students were chosen who were more than 130 centimeters? It would be 150 minus 92 all over 150. And that works out to be 48 over 150, which we can break down, if you want, into 24 over 75. We've now come to the end of CSEC past paper questions in the topic of statistics. In our first video in this series, we looked at the first 5 years past paper questions from May 2009 until 2013. And then in our second video from 2014 until 2018. And in this third video, we've done from 2019 until the present. Don't forget to look at the description down below so you can get a better gist of the entire CSEC Math syllabus.